Hey. So today we are going to start looking at quadratic functions. So we have dealt with linear for the past month, anything and everything linear. Linear equations, linear functions, linear systems, linear inequalities. So we've learned a lot of information about linear functions. So remember, linear function is just the highest degree of 1. Okay, so our x is to the first power and our y, or our f of x, everything is to the first power. Now, when we step into the realm of quadratics, that's when we are looking at something that is squared, a highest power of 2. So we're just going to start off by looking at some key features of quadratics. So let's look at our toolbox. We've got a few new words. So parabola, vertex, axis of symmetry, and zeros, roots, solutions, which we have talked about just briefly, so we're going to dive a little deeper into those. So let's go ahead and just start off with parabola. So notice this is a quadratic. This is a graph of a quadratic. So if you look at this quadratic, this one has an upside down U shape to it. Okay? Quadratics, they have a shape, it's called a parabola. So parabolas are just U-shaped graphs. And they can be pointing up or down, and that just depends on what type of equation or function that we have. So parabolas, let's notice a few things. What can you tell me just by looking at this? So hopefully one thing you notice is it's nice and beautiful and symmetrical. Okay? So quadratics, the parabolas, they are always symmetrical. So since they're symmetrical, I can go ahead and find where the highest point is, and that is another word on our in our toolbox that is called the vertex. So since this is symmetrical, the vertex is going to be right in the middle. So I'm going to look at my two endpoints, okay, my two x-intercepts, and I'm going to find the middle. So it's not 10, I have a little back here. So I have about -8-ish, then 22, 24, 25. So I'm going to say about 11 looks like it would be in the middle. Okay, so this line that I just drew, this is my AOS, my axis of symmetry. Again, because parabolas are symmetric. So the axis of symmetry always cuts through our vertex. So our vertex looks like it's about 11, counting by twos again, so 10, 12, 14, 11, 15. That looks like what my vertex is. So what we've talked about before when we looked at graphs that weren't just linear, we had maximum relative maxes and relative mins. So our vertex is a relative max. It is the peak. It is the highest point of our parabola. The axis of symmetry always cuts through the vertex. And the axis of symmetry, since it's a line, it actually has an equation. So it is a vertical line, which means it cuts through the x-axis. So our axis of symmetry would be x equals 11. Okay, because it cuts through the x-axis at 11. So x equals 11. That would be the equation of the line of the axis of symmetry. All right, so let's go back to our toolbox. So parabola, we talked about that, just a U-shaped graph. So the vertex is either going to be the maximum or the minimum of our parabola. Axis of symmetry always cuts through the vertex. Oh, and now let's look at our zeros, our roots, our solutions. So again, we have talked briefly about this, but in case you don't remember, zeros, roots, solutions, it's all the x-intercepts. So just look and see, where does our graph intersect the x-axis? So here and here. So I'm going to say 25, 0. And this one I'm going to say like -9, -8, 0. Definitely not -10, so a little bit bigger than that. All right, so our x-intercepts, those are also known as roots, zeros, or solutions. Okay, so again, we have talked about this just a little bit, but again, x-intercepts, roots, zeros, solutions, you can use any of those terms. So that is something you want to think about. So what information can be found by interpreting this graph? Okay. Well, by interpreting this graph, I look at my picture in the background. All right, I got somebody shooting a basketball. So what information? So my y-intercept, that's where he releases the ball. Okay, so that's one piece of information. I could find out the maximum height of the ball. It came up to about 15 feet. Let's see, what else can we tell? Well, I can tell that I was, well, this guy was about, let's see, where's this? Was shooting from about 19 feet from the basket. Do you see how I'm saying that? So I look at where the basketball would be going in the basket. So that's about, so from him to the basket was about 19 feet. Let's see. So in a real world application, would I be using the graph in this entirety? No, because I'm not throwing the basketball. He's not, you know, turning around and throwing it behind his back. Okay, we're not reaching behind us. So we see the release point, how the ball travels. If it hits the basket, well, then it would, the parabola would not complete. Okay, this is a full trajectory. So here we have a complete parabola, but in a real world scenario, you're really just looking at the pieces that work for you. However, whenever you have something that has that arch, that is a parabola. It has quadratic features. So we can extrapolate a lot of information just depending on what we're looking for. Okay, so let's just say in general. So it says, what's the difference between standard form and factored form? So standard form, ax squared plus bx plus c, this just continues to add terms as we go up to like cubic functions, fourth degree, fifth degree. So we just continue to add terms, but basically it's just talking about putting things in standard form, highest degree to smallest degree. So when we're looking specifically at a quadratic, there are a couple pieces of information we can gain from this. First off, A. A tells us the direction and the shape of our graph. And what I mean by direction is it a upside down U? So basically, is it a frowny face or a smiley face if we're talking in general terms? So if it's positive, it's going to be smiling. If A is negative, it will be frowning. So this is a negative function, the one we were given first. Okay. It also affects the shape, so how wide or how narrow our parabola is. Now C is going to be something familiar. C is our y-intercept. Okay, like y equals mx plus b, how b was our y-intercept. Basically, if you got a constant at the end, that's going to be your y-intercept, no matter what kind of function. So that's nice. If you have a constant at the end, that is your y-intercept. All right, now factored form. Factored form, so this first one is an example of a standard form. This is an example of factored form. So hopefully that looks familiar to you when we found our zeros. We set it equal to 0. So factored form allows us to find our zeros. Remember, our zeros, our roots, mainly our x-intercepts. Okay, so zeros help us to find our x-intercept. So graphically, that's different pieces that we can find depending on which form. So we're going to deal a lot with putting something from standard form into factored form because it helps us to find our roots. So we can find different pieces depending on which information we're trying to find. So what does factored form help us to find? Help us to find the roots. So if I look at this, x minus 3, if I set it equal to 0, I have an x-intercept at 3. So x minus 5, same thing. If you set it equal to 0, we have an x-intercept at 5. So if I were to graph this, oh, that is not straight. Okay. Okay, so if I were to graph this, I would have x-intercepts at positive 3. 1, 2, 3, 4, positive 5. Now, since my a term, that's out front, and all of my x's, everything is positive, this a term out front, my x's are positive, so I know that I'm going to have a happy graph. So it's going to be smiling. And again, this is just a generic shape. We're going to get into more detail on how to find pieces of our graphs. Okay, so standard form, I'm not going to get into that too much. All I know right now, just by looking at this, what's 30 tell me? I have a y-intercept at 30. So 0, 30 is my y-intercept. My a term, positive 2, tells me, hey, this is going to be a smiling graph. And the 2 is telling me it's growing twice as fast, so it's going to be a little more narrow than usual. Again, we're going to get a lot more into this. Today, we're just kind of talking like an overview of different pieces of quadratics that we can see, whether it's graphically or when we're given an equation and the type of equation. Okay? So this was just an intro. I just kind of want you to look at tonight's homework. It's just taking some real world applications and looking at the graphs and figuring out, well, what information can we gain? All right, good luck. I will talk to you later. Have a great day.